Hi again. In this lesson, I'm gonna graph polynomial functions. And we're gonna graph from factored form. So there'll be a different lesson where it's not factored, and then we'll use the remainder theorem and syntactic division and all of that to put it in factored form so we could graph it or find the zeros or so on. So with graphing this, my focus is basically which direction or end behavior on the right side and left side is it, and also we're not going to worry about y-intercepts. We're not going to worry about how far up does it go and how far down does it go. I mean, with max, local maximum and local mins. No, we're just going to focus on the behavior of the graph. So I'm going to do the first example, which is the basic one there. It's so the first thing here, for example one, which is y equals negative x minus 2, and x plus 3. The first thing you need to know is find out is are your zeros. So the zeros here, this x here is by itself, nothing added or subtracted from it, so that gives you a 0 that's 0, or an x-intercept that equals 0. So zeros is the same as an x-intercept. This gives you a 0 of 2, and this gives you a 0 of negative 3. Now, the leading coefficient is negative. So if the leading coefficient is negative, then your graph on the far right, like your 0 on the furthest 0 to the right, you should be going down. And this is the most important thing. I think if you remember this, you could graph any function. It doesn't matter what the degree is, as long as it's in factored form without any issues. You don't have to memorize anything. One thing you should know is what I'm going to show you. Okay. So now the first thing I'm going to plot my 0. So I have a 0 at 0. Whenever you have a 0 that's 0 or an x-intercept that's 0, then you know the y-intercept is 0. Just it goes without saying. Now my other 0 is 2, and my other 0 is negative 3, right there. So now we come to this point right here. So I said if the leading coefficient is negative, then your graph goes down from the 0 on the far right. So always the way I graph, I go to my 0 on the far right, and then if it's negative, I say, okay, this is going down right here. And then, you go up, you don't know how much you go up, and you don't have to worry about that. And then you go through this 0 right here, and you go through that 0 right there. And this graph is finished. If they want to ask you about end behavior now from graphing this, as x goes to negative infinity, that means as the graph moves more to the left, so as you're moving on the x side on the left, what's happening to the y, as you're moving to the left, it keeps on going up. So y is going to positive infinity. And then as x goes to infinity, that means as you're moving this way on the graph, so x is going further and further this way, what's happening to the y, you see we're heading down to negative infinity. And that's your end behavior. Okay. So this is it for this question. So I'm just going to erase it and move on to the second question. Example 2, and that is y equals x minus 2 and x plus 3. One is squared and one is cubed. Now here we have to talk about multiplicity. Sounds like a big word, but really nothing to it. Okay, so once you start listing your zeros for this one, which is x equals 2 and negative 3, so you say x equals 2, and it's a multiplicity of 2. And the reason it's multiplicity of 2 because of the square right there. And x equals negative 3, it's a multiplicity of 3. So what does that mean? Multiplicity of 2 means if you have a 0, as soon as you hit the graph, you bounce. So it could be bouncing this way, or you could be coming this way and bouncing the other way. But if it's cubic and a multiplicity of 3, if you have a 0, what you do, you go through that 0 for a bit longer. So you kind of go through the 0 for a bit longer, but you don't bounce. You go in a different direction. You come back this here and you go that way. So I'm going to plot my zeros, which are x equals 2 and x equals negative 3. And I'm just going to, yeah, there you go. So x equals 2 right here, and x equals negative 3 right there. Now, the leading coefficient here is positive, because it's positive and fraud here is different than having the negative right there. So if you have positive leading coefficient, you go to the 0 on the far right and you go up. So this is basically it. If the leading coefficient is positive, go find your 0 that's furthest to the right, go there, and you know you're going to go up. But at x equals 2, it's a multiplicity of 2. So I'm kind of going to do like a little bit of a curve here. So it's doing this. All right. Now, because at 2, you have a multiplicity of 2, you don't go through the 0 like last time. You don't just go through. It's a bounce. You have to bounce right of that 0. Okay. And then you come back to this here. Now, at negative 3, you have a multiplicity of 3. And a multiplicity of 3 means you come to this 0, you go through it for a bit longer, and you continue going down. That's basically it. So here, just to go over this again, if the leading coefficient is positive, go to your 0 on the furthest to the right and go up, and then follow suit. Multiplicity of 2 means you bouncing. Multiplicity of 3 means you're going through the 0 for a bit longer. So this is what multiplicity is. And then you just follow suit. After that, if they're asking you about the end behavior, then you could answer what the end behavior is. So here, the end behavior as x goes to negative infinity. So that means as x goes this way, as we're moving this way, that's what it means when I say as x goes to negative infinity. What I mean as we're moving further to the left. What's happening to the y? So as we move further to the left, the y is moving towards negative infinity. And as x moving further to the right, which is going to positive infinity this way, then y here is also going to positive infinity, because as we move to the right, following this graph, the graph is heading up to positive infinity. And this is the end behavior. Now we'll hold on to, we're going to do the third question, but let me just bring something to your attention. If the degree of the polynomial is even, both ends will go into the same direction. So they either go up or they go down. Odd polynomials, the ends, they go into different directions. Even, they go into the same direction. So if you count here how many degrees, it's 1, and this has a 1, and this has a 1, you count them, it's a 3. So that's why this is odd, and that's why different directions. This also, this is degree 2 and 3, that's degree 5. So they go into different directions. Also, the last one is going to be Oh, the last one is going to be even degrees. So that's good. 2 plus 1 plus 3, that's going to give me 6. So I'll show you why and why I'm saying that. If the degree is even, both ends will go to this either up or down. But again, your focus should be on what I'm telling you. Find the zeros. And then if it's positive, go to your 0 to the far right, you go up. If it's negative, you go to your 0 to the far left and to the far right, sorry, and go down. And then you just follow your multiplicities and start graphing your curve, and you'll be able to see it. Okay, so let's go to example 3. So with this example right here, let's just say the leading coefficient is negative. And then list my zeros. So x equals 0. It's a multiplicity of 2. X equals negative 2. It's a multiplicity of 1 because there's 1 on top right here. And x equals 4. It's a multiplicity of 3. So this here, you'll have a bouncing either up or down. This here, if you have a 0, you'll go right through. And here, multiplicity of 3, if you have a 0, you'll just go through it a little bit longer. That's what it means. Okay, so now look, let's go on and plot all these zeros. So I have a 0 at 0 right there, and I have 1 at negative 2, and I have 1 at 4. Now the leading coefficient is negative. That means I go to this 0 here, and I go down. If it's positive, of course, I would have gone up. But because the leading coefficient is negative, I go to my 0 on the furthest right and go down. But now remember, at 4, which is this is the 4, and this is the negative 2. At 4, it's a multiplicity of 3, so I should be going down. I should be going through it a bit longer. So what I'm going to do, I'm going to go through this 0 a bit longer, just so that now, because of its leading coefficient is negative, it's going to go down. Now it's going through that 0 for a bit longer, and then it goes up. And now when I'm coming back to this 0, it's a multiplicity of 2, so I should be bouncing. So I come back here and then, oops, bounce. You know what, I'm just gonna, yeah, so I'm just gonna do this a little bit. So here, and then I come this to here and bounce. And then I come here, and this is a multiplicity of 1, so I just go right through it. So that is how the graph looks like. Of course, you know, don't worry about the accuracy here. How far you go up, or that doesn't matter. You're not responsible for that. The most important thing is the behavior here, you know. This, that, multiplicity of 2, multiplicity of 1, multiplicity of 3. Or end behavior. As x goes to negative infinity, y also goes to negative infinity. And as x goes to positive infinity, y also goes to, y doesn't go to positive, it goes to negative infinity. So what it means when I say x goes to negative infinity, again, as the graph is moving to the left, y is going down to negative infinity. Also, as the graph is moving further right, going to positive infinity, the y behavior, you could see I'm heading for the negative infinity for y, and that's what it means. Okay, so next time I'm gonna do the remainder theorem and all of that stuff, synthetic division, questions like that. So I'm gonna be bouncing between logs and polynomials. Again, really important. If you watch this video, just don't ignore everything that's been said by the book, or you know, I don't want to, you know, I don't want to take any credit from anybody, but I just, for me, this is the easiest way to graph these kind of graphs. find out the zeros, find out the multiplicity. And then the catch is, if its leading coefficient is positive, go to the 0 to the furthest right, go up, and then start follow the behavior of the graph according to the multiplicity and all that. And if it's negative, go to the 0, the furthest to the right, and go down, and then just start following suit. You don't have to tell them what the end behavior is right away or anything like that. After you graph it, when it's in factored form, you could do that. Math is like a puzzle, and puzzles are fun to solve. Thank you for watching, and I hope this helps you guys do much better in your exams and your school and gain more confidence with math. Bye-bye.